In this video walkthrough lesson, we're going to continue looking at our fractions module, and this is lesson 5-1.4, understanding and creating equivalent fractions that are greater than one whole. We've worked with unit fractions, 1/2, 1/3, non-unit fractions, 2/3, making equivalents for all those fractions, but now our focus is upon fractions that are greater than one whole. And we'll be using fraction strips, number line, array method, the area model, and we'll be handling equivalents with fractions greater than one whole mathematically as well. These are the standards which are featured in this video, and we'll be using this worksheet. You can go to worksheetsandwalkthroughs.com to print out a copy for yourself. You'll find it under our fractions video walkthroughs. It's entitled Fractions Module, lesson number 5-1.4, understanding and creating equivalent fractions greater than one whole. Directions. Fold a blank fraction strip into 4 equal parts. Unfold it and label each section. Then lay the fraction strip below the number line and mark off 0, 1, which will be in the center, and 2 above the line, and 0 halves, 1 half, 2 halves, 3 halves, and 4 halves below the line. Then make equivalent fractions, 3 halves, 6 fourths, 9 sixths, 12 eighths, in the chart below. Again, we'll be using the array method, the area model, and we'll be handling equivalents mathematically as well. You'll also notice that included with this lesson as well are blank fraction strips and divided fraction strips if you need them. Let's continue. If you want to pause the video and cut out your fraction strips, label them as I've shown up here, you can go ahead and do that and resume the video when you're ready. Okay, let's get started. As you can see, we have our fraction strip, which is divided into 4 equal parts. You can fold it in half and then half again to make 4 equivalent sections. Now you'll notice that I don't have this strip divided into fourths because we want to show a fraction that's greater than one whole. So our emphasis this time is focusing on 3 halves. Before we do that, let's take a look at the directions on the sheet, and we will label above the number line our starting point of 0, and we'll also label the halfway point on here, which is actually one whole. And then we'll travel from left to right all the way to the end, and you'll see that we have, in fact, two whole. Now, you can always compare fractions on a number line to linear distance. Now, if you were to run a race, I've used this example before, but if you were to run a race, and you were to travel, you start here at the starting line and you travel, okay, we're going 1/2 a kilometer and then another or 2 halves of a kilometer, and you'll get to 1 whole kilometer. And it really looks you're halfway finished with your race. However, if you continue and you want 3 halves of the way, which is the fraction greater than 1 whole that we're working on. So if you travel 3 halves, you'll see that you are actually traveling the distance 1 1/2. So you'll see that our distance that our little runner here has run would be, let me just write that in there for you. There's 1 whole, and then there's 1/2 of another. It could be kilometers. So 1 1/2 kilometers, okay. So we've got this distance here as 3 halves. So let's label the rest of the number line right now. So we'll take a look at labeling these in terms of halves. Okay, there would be 0 halves at the starting line. If you travel 1/2 a kilometer, you'd have this fraction right here, 1/2, and then you'd be traveling 2 halves or 1 whole. as you can see above the number line up here. There's one whole up here. Then, like I said, we'll travel 3 halves. You might think of that as an improper fraction. Anytime you have your numerator exceeding your denominator or greater than your denominator, you're going to have a fraction that's greater than 1 whole. And that's what we have going on here. And then if you did finish the race, you would travel all the way to the end. This was a, I don't know, 2-kilometer race, for example. You can see the 2 up there. That would actually be 4 halves. Okay. So now let's take this linear thinking of fractions and once again apply it to our area models. So we've got to take some time and divide up our areas into 1/2. So you can see, and you'll divide them in half. Take some time to do that. I'll just use my line tool here. You can take a pencil, if you have a ruler, that'd be fantastic. See if I've extended that long enough. I have not. So let me just back this up. So here we go. All right, let's try this again. Now we'll divide these in halves. And these again, we'll split them right down the center, partition it into 2 equal parts. We'll slide this over. I mean, your parts should be equivalent when you're dealing with fractions. All right, so now we can begin. I want to show, like I said, we're going to emphasize this fraction here, 3 halves. And we want to show that as an area. And if you look at this group here, let me just emphasize that a little bit. We're looking at these 2 together here. Okay, we've got 2 whole areas. Okay, and you want to split them up each into halves. So each whole is made up of 2 equal parts. Now, like I said, we want to represent 3 halves, so let's shade those in. You can take a highlighter if you have one, or you just shade it in with your pencil, that's fine too. So we'll shade in 1/2, 2 halves. I'm moving too quickly for you. Feel free to pause the video and just resume when you're ready. So there we go. We've got 3 halves there. And I'm going to continue this all the way down. Because we're building equivalent fractions. Fractions equivalent to 3 halves or 1/2. If you're dealing with a mixed number, 1/2 would be the same as 3 halves. We've kind of proved that in terms of kilometers up above on the number line. So we'll just keep shading in these just to show equivalence later on, like we've done in our previous fraction module lessons. Just keep this right up. 1/2, 2 halves, 3 halves out of these as well. And your shading, you don't have to be super perfect, but it's fine. It's just you could quickly shade them in if you want to. And now we can see that right here, that would be 3 halves. So also the directions say that we need to show 6/4 as well. So let's do that next. We'll partition this next set of 2 down here. Okay. We're going to partition that once again. We'll divide it, actually partition it twice, really, because you've got 1, 2 more divisions across here. So each whole is now made up of 4 equal parts, so you're probably thinking, those are fourths, and you'd be exactly right. So working off of our original fraction, greater than 1 whole, so like I said, that numerator is greater than the denominator, so you know you're dealing with more than 1 whole. All right, so now we want to make this equal to a fraction with a denominator of 4, because now we have 4 parts that equal our 1 whole. So we'll right off the bat, we know that denominator. So mathematically, we can handle this. We can say, okay, 2 times what equals 4? And yeah, I bet you're thinking this. 2 times 2 equals 4, and you'd be right. So good for you. And what you do to the numerator, or denominator, what you do to the denominator, and we did first this time, you have to do to the numerator. And again, you're really multiplying 3 halves times this fraction, 2 over 2, which you're probably thinking is 1 whole. So again, you're not changing the value, or actually how much your fraction represents at all. So now let's check it out. 3 times 2, you're probably thinking 6. Good for you. So we'll get that in there. 6/4. Aha. So now we can label this as 6/4. And you can probably see the equivalence going on right there. You can see this area is equal to this area in our area model. So 6/4 of the same wholes are equivalent. You can check that out. All right, so now we'll move on and we'll build our next fraction, our next equivalent fraction. So again, we're working off 3 halves. And this time we want to subdivide it into, subdivide it three ways. Okay, so here we go. We've got, as you can see, let me just adjust that a little bit. If you're working with a pencil, you can try to get this as close as possible. Fortunately, I had the opportunity to change it this way. So there we go. Now we've subdivided again by 3. So we've got 3 parts going across here. We've subdivided it here, partitioned it 3 ways now. So we can think of that as, you know, either multiplying by 3 over 3. You could do it that way. Or, like we did before, we could set it equal to a fraction whose denominator is, you can take a look at this, how many equal parts do you see there? 6. Yeah, right. So now we want to take a look at 6 as our denominator. There are 6 equal parts to make up our whole. So now, again, you're probably thinking to yourself, okay, 2 times something equals 6. That would be 3. Good. So 2 times 3 would be 6. We'll treat that numerator the same. 3 times 3 equals 9. So another equivalent fraction to 3 halves would be 9/6. So let's show that over here. We've got 9/6. That's also equivalent. So now we'll go on to our last equivalent fraction. And again, we'll build off our original fraction. All right, we've got 3 halves. And we want to partition it again so that we're going to make the fraction. If you looked at the worksheet, you'd see that we're now dealing with eighths. So that really means we're going to go ahead and subdivide this, or partition it once again across horizontally. So we're making, well, I have to write in 3 lines, but really partitioning it by 4. Okay, so now we started off with the original 3 halves, and we're going to multiply the denominator and numerator by something. And one thing we know right off the bat, as you can see, that our new denominator should be, we've got 8 equal parts, so that just only makes sense that our denominator will be 8, because it takes 8 equal parts to make 1 whole. And now we'll multiply to solve for what our numerator would be. So 2 times something equals 8. So you're probably thinking, again, 2 times 4 would equal 8, and you'd be absolutely correct. So now, probably used to this by now, we handle the numerator and denominator the same way. What you do to the denominator, you must do to the numerator. Can't repeat that enough. We're multiplying it in essence by 4 over 4, or 1. So again, we're not changing how much the fraction represents at all. So let's go ahead and do this. 3 times 4 equals 12. There you go. So now we've got 12/8. We'll show that over here. And there you go. And you can see that all these fractions are equivalent. So 12/8 is equivalent to 3/2. So therefore, it must be equal to 6/4 and also 9/6. They are all equivalent fractions that are greater than 1 whole. So now how do we handle the array method? Well, what you need to do, again, like we've done previously, is to take a look at that denominator. So the denominator tells us that we need to have 2 parts to our set or group. You could imagine this is a beach volleyball team, and there are 2 members of the beach volleyball team. So 2 people make up one team or one group. So, however, since we have a fraction that's greater than 1 whole, we need more than one array or set. So let's take a look at making another one with 2 parts that make up that whole set. So there's one set and there's another. Now we need to look at 3 of those. So there's 1/2 of one set, 1/2 of another. There's 1/2 of the second set. Now we've got 3/2. So this is equivalent to 3/2. So that's the array, or the 2 arrays that show 3/2. Okay, so now we'll take a look at this second equivalent fraction greater than 1 whole, and we've got a denominator of 4. So you're probably thinking, okay, our arrays or our sets will have 4 parts. And you're exactly right. So we've got 1, 2, 3, 4. And again, since the numerator is bigger than your denominator, you're going to have more than one. So we have 2 in this case. And I know that we've had 1/2. Look at that, 1.5 of each of these. So let's see what happens now. We'll do 1, 2, 3, 4, 5, 6. Look at that. That would be 6/4. Now, how can we see the equivalence in that? Well, if you look up here, we had 2 groups with 2 in each. And we had 1 whole group and 1/2 of another group. And look what's going on here. We have 1 whole group and half of another group, showing 6/4. So in essence, it's really equivalent to 1.5, just like we showed on our number line up above. And you can see it here. This is 1/2. I'm sorry, this is 1 and 1/2. And so is this. We have 1 whole group and 1/2 of another. And you can see that pattern kind of continuing. So there's 6/4 as an array. We're using the array method. So now we're going to take a look at this denominator of 6. And you can probably go ahead and guess. We've got a group of 6 here, and we need another group of 6 to show our fraction that's greater than 1 whole, because we'll have more than one. And let's check out what happens. So we've got to have 9/6. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. And you can see that we have 1/2 of one group. I'm sorry, we have 1 whole group and 1/2 of another. You can see that pattern continuing. Look at that. And let's figure out this last one here. We have 12/8. So you're probably thinking our denominator tells us how many we need to have in each group or set. So we'll have 1, 2, 3, 4, 5, 6, 7, 8. Matches our denominator. And since it's more than 1 whole, 12 is greater than 8. Our numerator is greater than our denominator, so we'll have to have more than one. We'll set up another array with 8 in it, or another group that has 8 in it. And now we have to focus in on 12 of those. So we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you can see that pattern. Isn't that pretty cool? We've got one whole group, half of another, a whole and half of another, a whole and half of another, one whole and one half of another. So these are all equivalent to 1.5. So they are all equivalent fractions. Now you can stop the video if you'd like, and I'm just going to do a little additional work again and compare these improper or fractions greater than one whole to our fraction we started with, 3/2. So let's check out, see how this works. So now, in these, we have to have, like our array will help us out, or if you look at our area, in total we had, okay, we have 8 sections here. So I'm going to have to choose a number line that has 8 equal parts. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. That won't work. Let's try this one. 1, 2, 3, 4, 5, 6, 7, 8. Ah, that's the one we need. So what we'll do is this. We'll drag this over here. And you can see if we looked at this in terms of fourths, you can see one whole would be 1, 2, 3, 4. 4 fourths would make one whole. 5 fourths, 6 fourths would be right there, and it would line right up. You can see that. Kind of lines right up there. They're equivalent. So now we'll handle the next one. We're looking for 6. However, we've got 2 whole, so we'll need to look for 6 plus 6 is 12. Let's see what we've got here. Okay, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. So we'll drag this one across and put this line this right up here. And again, these are 6. So 1, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6 was equal to 1 whole. That lines right up with 1 whole. 7, 8, 9, 6 would line up right there with 3/2 with 6 fourths. They are equivalent. And the last one, we've got eighths we're dealing with. However, we've got 2 wholes, so there are actually 16 eighths there, who will equal 2 whole. So let's take a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so we need 16 parts to really equal 2 whole for this one. Okay, so now again we're dealing with eighths, so it would be 1/8, 2, 3, 4/8, 5/8, 6/8, 7/8, 8/8. 8/8 would be 1 whole. That figures right out. That lines right up. 9/8, 10/8, 11/8, 12/8, and look at that. They do all line up. So let's kind of show that quickly. We can show the equivalence there. They all are equivalent. And you can see that in terms of distance, our runner has run the same amount or distance, whether it be 3/2, 6 fourths, and let's move that down so you can see our fractions as well. So we've got 3/2, 6 fourths, 9, 6, and 12/8. They all line up there. You can see they're equivalent. We could see our equivalence linearly as well. So that was a quick look at understanding and creating equivalent fractions that are greater than 1 whole. Thanks for checking out Worksheets and Walkthroughs.com, and we'll see you again next time.